Welcome to Module 2 of iOS Social Media Forensics. This is the first lecture of the second module, and this will be a bit of a supplementary lecture. In this lecture, we will basically go through an introduction to SQL. We will learn what SQL is and what it is used for. We'll go through basic SQL syntax, and we will learn about SQL joins. If these things sound familiar, if you have any experience with SQL either at work or maybe at school or university, this will probably be rather basic for you, but it's still a good refresher, so I encourage you to stay and go through this lecture with us. Alternatively, as a measure of success of this lecture, there's an online quiz on the W3 Schools website, and it's linked in this module. So if you're feeling confident, please feel free to click the link, attempt the quiz. There are 25 questions. Hopefully it should not take you more than half an hour to complete the test, and it has a good variety of topics that we're covering as well. If you got around 60-70% on that test, you should be fine. Why 60 or 70? Because a couple of questions are about modifying the contents of a database or deleting things from databases, and that's not an area that we are going to focus on, because we are going to be retrieving and organizing and contextualizing data rather than modifying it. So you don't need to focus on these parts. So let's begin. What is SQL? SQL stands for Structured Query Language. It is used to communicate with databases. So we can use SQL to alter, manipulate, filter, retrieve data from relational databases. You can create databases using SQL. You can create tables in databases. You can, of course, retrieve and query the database. So make the database, extract the data of interest from the database based on your query. Or you can also modify it. You can update or delete records. This is something that we're not going to look into very closely, but if you are interested in learning more, you can go through the whole SQL course on W3 Schools. This is a free website. I hope I said that already, but in case I have not, it is free. And feel free to revise some more after this lecture as well, if you want to. There's a variety of SQL topics on W3 Schools. So why am I pushing W3 Schools so much? The course is very good because it is free. It eliminates the need to set up your own database to start with, because it's all simulated in the browser. You can have a go and try and execute different SQL queries in your browser without setting anything up. So that's obviously very good and very user-friendly. It also has challenges and quizzes that tests your understanding of different topics as the course progresses. And there are short and comprehensive descriptions of all topics. So it's a really good reference for whenever you need to use SQL. I use it at work as well. It's a wonderful resource. So even if you don't need to use it right now, keep it in mind as a future reference. So let's start with the basics. An SQL query is the basic unit of an SQL query is an SQL statement. It will be think of it like one command that you give to the database specifying the kind of data that you want it to return. an SQL statement will end in a semicolon. Not every version of SQL will require that, but just for the sake of interoperability, let's keep it, and let's always at the end of an SQL statement put a semicolon. So an example of a statement would be return all of the rows in the table customers, for example. We will look at the syntax in just a second, but just in terms of what we want to happen, like we want all customers from all rows from the table customers. You can kind of chain the statements into longer queries using logical operators such as or, and not, etc. So if you need your data to fulfill a couple of conditions, you can construct a longer statement using these operators. And the statements are created starting with verbs such as select, update, delete, etc. These are this is not an exhaustive list. There are many more of those, and such as create table, alter table, delete table. But for our use case, for the sake of analyzing the iPhone backup and analyzing the databases in the backup, we will mostly be using select, because as forensic investigators, we don't really plan on changing the data. What we're doing is analyzing. So we're going to be selecting, which is kind of like just retrieving based on a query that queries that we will construct. Let's take a look at some real-life examples of SQL statements. Obviously, it's easiest to just see how they work in practice instead of just going through the theory on its own. So let's look at the table here, the table employees. There's a unique key, employee ID. So here we just have integers incrementing by 1 with each row. So 1, 2, 3, 4, 5, and every next employee would have to have a unique ID as well. So these cannot ever repeat. And we have 5 employees. We have their names, their surnames, and the role. So here's a couple of examples of how we could query this table. So first, if we want to show all employees, we would use the statement select asterisk from employees. Let's look at a couple of details here. So first, you can see that we write the verb select and then the word from in all caps. That's a just conventional. So if you want to follow that, please do. And employees is the name of the table. And what is the asterisk? Asterisk is a bit of like a wild card, just means everything. So if you want to see the whole contents of a given table, always go select asterisk from and then name of the table. So let's move on to a little bit more complicated examples. What if we wanted to see all employees whose first name starts with the letter T? So you can see I've highlighted bits of this SQL statement here for your convenience. So you can see that the start is the same as show all employees, because obviously the data we're going to be filtering in the second part is the whole of the table. So we're not selecting only name or surname or role. We want to see all of the columns. And then we add the condition where name, because that's the name of one of the fields or columns, like T, and then %sign. So this means that the first letter has to be T and then anything after T. Is that clear? I hope it is. If not, please have a look at free schools, or write a comment or on the forum, or ask a question, and I'm happy to provide more examples, but I hope that it is quite clear. And now let's look at yet another thing that we can do, which is how to see names and surnames only, because now each time that we do select asterisk, we get all 4 fields, right? So we get employee ID, name, surname, and role for all the rows that that fulfill our requirements. But what if we don't care about the employee ID or the role? That's just noise to us. So we just want to know the name and the surname of all engineers in that company. So we specify, instead of the asterisk, we specify which fields or columns will be displayed. So select name, surname from employees, where role equals engineer. So here we are using the equal sign as opposed to the like keyword, because we want an exact match. This is not a like partial matching like regular expression. This is just the contents of that field has to be engineer exactly, and nothing else. Now that we've learned how to query a table, a single table in an SQL database using an SQL statement, let's think about what happens if we have more than one table, which is often the case. Databases are often made up of multiple tables, and we frequently need data from more than one table. We want to see it together. We want to collate it to be able to contextualize it and be able to make sense of it. So let's talk about SQL joins. SQL joins are clauses that make it possible to join 2 tables if they share at least one column. So that doesn't mean that it's the same column exactly, but they have to both have that column so that they can act as the point of reference, and you join the 2 tables on that column. So for example, let's think of an example of customers and orders, 2 tables in a database of an online store, let's say. So each customer will have a unique customer ID, and let's say other fields or other columns in the customers table would be name, surname, and address. And in the orders table we will have the customer ID and maybe the type of an item bought and the quantity, but we will not have the name and surname because we don't need to. We already referenced the customer by the customer ID, and we might want to be able to query the database in a way that we get the surname of the customer and the name of the item that they bought. That's where SQL joins come to play. The 4 types of joins that we'll talk about is the inner join, left join, right join, and full outer join. So this looks a bit mathsy, I would say. Don't get scared. Just imagine that the circles in the slide are just tables. So if we use inner join, which is the most popular type of a join, the only rows that are returned are if both the table on the left, let's say, so both customers and both orders have an entry for this specified query. If they don't, then it is not returned. The left join includes all the entries in the left table. So for example, in our example, the whole table of customers, as well as the rows from table 2 orders for the customers who made any orders. In case some customers made 0 orders, there will just be a null value next to their name in the output of the join. The right join is the same, but kind of a mirror reflection of the left join. So all table 2 rows are printed. So for example, in our hypothetical example, all orders ever placed, and the customers from the left table, from the customers table, who have placed any orders. Probably in our example that would not really be a problem, because in a let's think logically, probably you can't have an order without a customer, so maybe it's not the best example for the right join, but there are all sorts of databases and it makes sense for other use cases. And full outer join just returns both the table on the left and the table on the right, so basically everything. You need to be very careful, because performing the full outer join can sometimes result in huge results, and that can freeze your computer. So you probably won't need it in this course, but just be aware that it exists. Once again, let's move on to practice and see what these joins would look like on a real life example. All right, so here we have 2 tables, a bit different than the orders and customers that I used in the last slide. So here we have the table employees that you have seen already, and now we have another table also that's called workstations. So workstations, let's say it's just an inventory of computers, personal computers or laptops that the employees are issued, and you can see that there's the location, either HQ or Office 1, where that machine is located, and the employee ID who the workstation belongs to on the left. So what if we wanted to collate the 2 tables? As we said before, to be able to do that, we need at least one column that's the same, and here we have it. So we have the employee ID, which is referenced both in the employees table and the workstations table. So let's note that surely that will be the column, the field on which we will be joining. So let's solve some questions considering this these 2 tables. I would advise you, if you can, please take a second and take a screenshot of this slide, just so that you can save the 2 tables to know what kind of fields there are to answer the questions of the next slide. Let me just give you 2 seconds, or pause the video and take a screenshot, and when you're done, let's move on. So question number 1, and let's call it a worked example. So I'm going to walk you through this one. So here we want to show the name and the surname and the location of all the employees. So what is the biggest challenge here, really? Well, if you refer back to the slide before, remember that we have name and surname in the employees table, but the location is in the workstations table, which means that we will have to join the two tables to be able to get our data. So how do we write that? Alright, so we start with name, but this time we have to specify from which table the field that we want comes from. So that's why we write employees.name, employees.surname, and workstations.location. This is because field names do not necessarily have to be unique. So you could have fields that are called the same with the same word in different tables. So this is to make sure that it is coming from the right table. So then we say from employees, and this is our left table, and then we say left join workstations on employees.employee_id equals workstations.employee_id, and a semicolon to finish off the statement. All right, so our next question is show the surnames and the endpoint IDs of all the engineers. So I would like you to have a couple of minutes of thinking, have a think about how you would answer this, what kind of an SQL statement you would construct to get the data that you want. Pause this video, take a few minutes, and then please resume to see the worked answer. So the answer is this. And now let's go through it. So we want to see surnames and the endpoint IDs. That's why we are selecting two fields, surname and endpoint ID, from respectively the employees tables and the workstations tables. So this is this part. We want to see all engineers, so we start with employees table, and then we left join workstations. To be honest, both of these tables are full. There are no unmatched values. They will always perfectly match. So this is like we wouldn't get any null values anyway, but just to be diligent, we're using the left join. So we join the workstations on the employee ID field, obviously, because this is the one that we are always joining on, the common field, where the role is equal to engineer. Let's look at another example. Okay, so this is the second question, and let's do the same. Show all employees, name and surname, who are based in the HQ. So please take a second to try and think of the answer on your own. Pause the video, and when you're done, come back and check your answer. So once again, we get name and surname, this time both from the same table, because both name and surname reside in employees. And we start with the employees table. We left join the workstation on the employee ID field, which we know is the common one. And now we filter by the location in workstations, which must be equal to HQ. So we've gone through all of the concepts, all of the basic SQL concepts that we need. So let's summarize before we go. So what's SQL? SQL is a structured language used to query databases. In our use case for our forensic analysis of iPhone backups, we will be mostly selecting, so basically searching in the database for things that interest us. We won't be changing much, we won't be deleting, we won't be updating database, just selecting. So we learned how to create SQL statements that will allow us to customize what data we want to change, add, delete, or retrieve mostly. We also learned about SQL joins, which allow us to collate data from different tables into one output, joining on a common field or column that both of these tables have. And we covered the inner, left, right and full outer join. Now, before we go and we move on to actual iOS social media forensics, which comes in the next lecture, so I hope you're excited because I am. Just to check if you're ready with your SQL knowledge. I mentioned it at the very beginning, but in case you were one of the beginners, this is the time to check your knowledge and complete the W3 Schools quiz. The link should be somewhere around here in the platform. In case you can't see it, you can also, you can't really copy and paste, but you can copy it manually from the slide. Again, don't worry about inserting, modifying, and deleting rows. Just make sure that you know the basics and the joins and the selects. If you get around 60-70% in that quiz, then you're ready, and please proceed to the next lecture. See you.